The last part in the kinetic is about catalyst. What is the definition of a catalyst? In the college, you studied that catalysts increase the rate of the reaction, and this characteristic of the catalyst suppose that the reaction is spontaneous. Also, for some reactions, we need to add catalyst to proceed it. So the catalyst is a substance added to the reaction system in order to make some non-spontaneous reactions spontaneous. And if the reaction is spontaneous, the addition of the catalyst increases the rate of this reaction. The catalysts are not consumed in a reaction system. The catalysts intervene in the reaction, but they appear in the equation of the reactants, they appear with the reactants, and they appear with the products, so they did not appear in the equation of the reaction. The catalysts are involved in intermediate step for a reaction. The catalyst A plus B, the reaction would not proceed for several reasons. First, the orientation of A with respect to B. Second, the collisions between A and B did not produce the minimum energy needed for the reaction to proceed or did not reach the activation energy. So the role of the catalyst is a friend of the reactant A and the friend of the reactant B. Since A and B are not in collision, the catalyst will invite A and will invite B, then will do the collision between A and B. The important role of the catalyst, suppose you have a reaction that needs where the activation energy is 35 kilojoule per mole. If the energy of the reactant of the collisions did not reach this value, the reaction would not proceed. So the catalyst adding a catalyst will decrease the activation energy, for example, of this reaction from 35 kilojoule per mole to 20 kilojoule per mole. And therefore, the reaction will proceed. So the main important functioning of the catalyst is the decreasing of the activation energy of a certain reaction. We have two types of catalyst. Homogeneous catalyst, when added, it forms one layer with the reactant. When you add the catalyst to the reactant, you could not distinguish two layers. You have only one layer. You have homogeneous system. So in this case, the catalyst added is homogeneous. The heterogeneous catalyst is a substance added, and you could distinguish your catalyst from the phase of the reactant. So you obtain at least two phases. And in this case, the catalyst is called heterogeneous. Why we use the term homogeneous and heterogeneous? The mode of functioning of the homogeneous catalyst is different from that of the heterogeneous. And for some reactions, we need homogeneous. For other reactions, we need heterogeneous. Which is better, homogeneous or heterogeneous? Now, in the science of chemistry, in the industry of chemistry, we prefer to use heterogeneous catalyst, since in most cases the catalysts are expansive, and if our catalyst use is homogeneous, then at the end of our reaction, we can regenerate this catalyst and reactivate it in order to use again in the chemical reaction. So the property of the catalyst neither appears in the balanced reaction. They do intervene. They intervene in the reactants as intermediate, but they appear in the product, so they did not appear in the equation of the reaction. And the term did not appear in the balanced reaction does not mean that the catalyst did not interact with the reactant. So the catalyst appears first as a reactant. Then an intermediate appears first as a product. So it's not usually possible for a chemist to identify or to characterize an intermediate. For this reason, when we use a catalyst, we have a certain pathway in the reaction. We have a certain mechanism. And since we could not isolate the intermediates during a chemical reaction, so we could not know exactly the mode of the functioning of the catalyst. For this reason, when we use a catalyst, we say propose a convenient mechanism or acceptable mechanism, since we could not isolate the intermediate in order to know what happens during the transformation of the reactants to products. So the catalyst lowers the activation energy by making a reaction mechanism, a different reaction mechanism possible. For example, consider the transformation of the reactants to products. The energy of the reactants is greater than the energy of the products. So the difference of the energy is negative. So the reaction I used is exothermic. What is the pathway? The pathway is the following. In the blue curve, the reaction follows this pathway in order to form the product. What is the activation energy for this reaction, which is not catalyzed? I did not use catalyst. The activation energy is the difference between the energy of the reactants and the energy of the activated complex. So this is the activation energy of the non-catalyzed reaction. Now I will add a catalyst to this reaction. When we add a catalyst to this reaction, the energy of the reactant and the energy of the product will be the same. The only change is the pathway of the reaction. So we will follow another pathway in dots. This is a catalyzed reaction, and as you observed, this pathway dots is different from the pathway in the blue curve. If we calculate again the activation energy of the catalyzed reaction, the activation energy is the difference between the energy of the reactant and the activated complex obtained in case of the catalyzed reaction. So this is the difference, and as you observe, this is another value of the activation energy called E prime. So E prime A is less than EA. As a conclusion, in the catalyzed reaction and the non-catalyzed reaction, the energy of the reactants and the energy of the product are intact. The pathway between reactants and the products are different, and the catalyzed reaction has activation energy lower than the non-catalyzed. The difference between the heterogeneous catalyst and the homogeneous catalyst, as we described previously, is the mode of action. The heterogeneous catalyst act as host for two guests, which are the reactants. So the heterogeneous catalyst work on its surface. Suppose I have the reaction of hydrogenation of ethene, and we know that ethene plus hydrogen form ethane. So this is the hydrogenation reaction of alkene. Without adding a catalyst, the reaction between hydrogen and ethene did not proceed, since the energy of the collisions did not reach the needed value or the activation energy of this reaction. Or in other words, we can say that the orientation of hydrogen and ethene did not allow for the reaction to proceed. So what is the effect of the catalyst added? In general, we add nickel catalyst or palladium, and the palladium on its surface, we have the brown balls. This is the active sites. This is a site that can receive a gas. So the hydrogen will do interaction with this active site, and the ethene will do interaction with other active site. So we will have a new figure. We have the surface of the catalyst, and we have a gas on the host, which is the active site, and we have ethene as another gas. So this is the first step. The second step, since the surface of the catalyst interact with ethene and hydrogen, so the catalyst is a friend of these two reactants. And now the collision between the hydrogen and ethene is easier, so they can interact between them to give the ethene on the surface of the catalyst. Then the surface of the catalyst will release ethane. So we have hydrogen and carbon. They did not react. They interact on the surface of the catalyst to form ethene. Look to the catalyst. The catalyst appear with the reactant, and the catalyst appear with the products, but the catalyst does not appear in the equation of the reaction. So the heterogeneous catalyst act on its surface, and we need presence of active sites. As the number of the active sites increase, we have better catalytic activity, and the heterogeneous catalyst does not intervene in the rate law expression. This is a very important note about heterogeneous catalysts. They do not appear in the equation of the rate law expression, since the heterogeneous catalyst is host and did not interact as real reactant. How to increase the efficiency of heterogeneous catalyst? By increasing the surface area. When we increase the surface area of the catalyst, we increase the presence of the active sites, so we increase the catalytic activity. We pass to the homogeneous. The homogeneous catalyst is a substance added that form one layer with the reaction system. If the heterogeneous did not appear in the rate law expression, the homogeneous does appear or appear in this expression. When we use higher concentration of the homogeneous catalyst in general, we increase the catalytic activity. Consider the reaction of decomposition of hydrogen peroxide to H2O and O2. In absence of the Br2 bromine, this reaction is very slow. The decomposition of H2O2 is very slow. If we add Br2 as a catalyst, the decomposition or the rate of the reaction is fast. So what is the mechanism? We can propose a mechanism. We can say that the decomposition of H2O2 occurs according to the following pathway. This is a pathway proposed. You could not propose. We give you the pathway. Br2 react with the H2O2. Pay attention. Br2 react with H2O2. So Br2, the homogeneous catalyst, is a real reactant. And this is not the case in heterogeneous. The heterogeneous act on the surface as host of two guests. But in the homogeneous, Br2 react with H2O2 to give Br minus H plus O2. Then Br minus react with H2O2 and H plus to give Br2 and H2O. Br2, the homogeneous catalyst, act as a real reactant, but it appears in the product. So Br2 is a catalyst. Br minus is a substance that is not present in the equation of the reaction. Br minus is a substance that appear in one reaction, in one step, then disappear in another step. So Br minus is an intermediate. So the catalyst appear in the reactants and appear in the products, appear in the reactants and appear in the product. So it does not appear in the equation of the reaction. The intermediate is a substance that appears, then disappears. So this is the intermediate, and the experimental rate law expression is R equal K times Br2 to the power 1 times H2O2 to the power 1. So the reaction is first order with respect to the catalyst and first order with respect to H2O2. In this case, the homogeneous catalyst appear in the rate law expression, and pay attention, the heterogeneous did not appear in the rate law expression. This is the main difference of homogeneous and heterogeneous catalysts on the rate law expression.